Okay, everyone in my Zoom session, could you all please raise your hands if you can hear me and you can see my screen? Okay, very good. And everyone can see my screen, I will assume. Any questions either here or from anyone in Zoom before we get started today?
Yes, I have one. I was trying to find the recorded lectures, but I couldn't figure out where they were.
Okay, so the question is, the person was trying to find the recorded lectures, but couldn't figure out where they were. So if you go to the website for the course, which is web EECS UTK tilde B Vander Z cs465 and go to lecture notes. And this link right here, lecture, those are my recorded lectures. And this tells you where to start from because there's a bit of stuff at the beginning where you see me, like today, there's about 3 minutes at the beginning where you're going to see me piddling around before I got things going.
Okay.
So if you click on them, you'll see their YouTube videos. And this is why you skip to 40 unless you'd like to watch my face doing things. But then it has the entire lecture. And usually I get these uploaded either the evening of the lecture or the next morning. Okay. Other questions? Okay. And someone asked if I could post a link on Canvas. I will do that. I will post a link to this page on Canvas. So we'll make that happen. Okay. Other questions? Please just speak up. I can't multitask with chat and the like. So you can chat among yourselves, but if you're going to ask a question, I need it verbally because I can't monitor multiple things at one time. Okay. So in that case, today we are going to start talking about MySQL queries. I had hoped that we would have databases for each of you by today, but that has not happened yet. And so I'm just got to keep after lab staff to try to get the databases created. They haven't created one for me yet either. What I am going to be doing today is using something called PHP MyAdmin. It looks a lot like MySQL Workbench that you read about today. So I'll be showing you how to execute SQL queries using that. I find it a lot easier to use the MySQL command line. And hopefully we'll have the databases by Tuesday so I can show you what's going on there. But feel free to download something like MySQL Workbench, install it, and do your queries there. Just make sure that they work on the department's machines because that's where we're going to test them. Okay, so this bigger. So in this course, we are going to use MySQL, which is a public domain version of SQL. SQL is owned by Oracle, developed by Oracle. It's the behemoth in the relational database market, and therefore that is what we will be using. In fact, most, I think, databases would try to follow roughly what the SQL standard just because of how ubiquitous it is. Actually, I think today I'm going to be using a different set of relations. So if you're looking at my slides, certainly going to Canvas and going for figure 4.3 under course materials. There's a course materials section in Canvas, and it might help you to follow along with the example queries, but I'm going to do some different queries in class. So here's the essence of the query language in SQL when you are trying to retrieve information. It's called select, project, join. So select filters rows based on some predicate. Project filters out columns, so you can specify you want some set of columns from a relation. And join connects information from multiple relations using foreign keys. This is your essential way of doing things. In fact, today, basically what we're going to be looking at is the fact that you can basically all queries come down to something like select column names from tables, or I'll call it table list, where predicate. So all tuples that match the predicate will be returned. So this right here is the project. And in some sense, this is the row filter. And this is the column filter. So that is the basic thing that you'll be using all semester long in order to retrieve stuff from a database. Now,
Dr. Van Zanten,
yes.
I'm sorry. What was that program you mentioned if we wanted to mess around with SQL before we got actual databases?
MySQL Workbench.
Okay.
It's if you look at I think it's section 15.5 of the book, and they have a small bit on MySQL Workbench.
Okay. Thank you.
You are welcome. Okay, so there we go. Okay, so there's 3 other commands that we will cover either at the end of this lecture or next lecture, and that's insert, update, and delete. And those 3 commands, which we will get to, allow you to add, modify, or delete data. But they're all essentially based on the select command. So everything kind of comes away from that. So when we are, let me get rid of the drawings. Sorry, actually, you're not, yes, you are seeing these drawings. Suck. What you can't see is I have a screen, separate screen that allows me to supposedly get rid of stuff. There we go. Okay. Okay, so it will seem that SQL is verbose. The reason for that was it was meant to be used by non-programmers. So it is more, most of you never saw COBOL, which was a popular business language in the 1970s and 1980s, but I think it was somewhat designed after that particular language to make it easier for non-programmers to create commands. So for you, it may seem somewhat verbose, but for non-programmers, it is something that's pretty readable. So here's an example of a select command right here. So we're selecting 3 columns from the staff relation of our property manager case study. And we're selecting from the staff relation, and we want all staff whose salary is greater than 10,000. So very simple query. Okay, so case sensitivity, the only thing that is case sensitive here at UTK with our MySQL server is the relation names. Everything else, your attribute names, the keywords, even your literal character data is case insensitive. If you do a comparison of Brad van der Zanden with the B's and V and Z capitalized and not capitalized, they will come back equal because our SQL interpreter ignores upper and lower case. The only thing it's sensitive to is relation names. Okay, just a note about readability, especially for your homework assignments. Generally, it's good to start each new part of a select statement on a separate line with indentation. So I know I didn't indent here, but select on one line, then the from on a separate line, then the where on a separate line. It makes it easier to read. So I'd appreciate that if in the homework assignments you try to adhere to that. And split up predicates in the obvious way. Oftentimes predicates won't fit entirely on one line. So it's good to split them often across multiple lines. Just do it in an intelligent way. Okay, an important thing in SQL, strings are enclosed in single quotes. It will work with our interpreter if you use double quotes, but please don't get in the habit of using double quotes to enclose strings. The reason is that SQL actually, the standard makes a distinction between single quotes and double quotes. Single quotes refers to character literals, string literals. Double quotes refers to things in the database such as column names. So you're actually allowed to have spaces in things like your attribute names or your relation names. So when you would be referring to things in the database like relation names or column names that have spaces, you would put double quotes around them. But when you're just dealing with character data that is stored in the database, that's single quotes. Okay, so please don't get in the habit of using double quotes because it's a bad habit. It will be accepted by our SQL interpreter, but it's bad practice. And I know it's a change for you because you're so used to using double quotes for string literals, but please, for this course, get in the habit of using single quotes for string literals. Okay, so a lot of stuff here. I'm just going to start to illustrate. The slides are nice, and the book also has nice stuff with the slides. What I'm going to do is just do a brief list of the where conditions, just like the book has. And then what I'm going to do is show you some sample queries. Okay, so the come up in a moment, just a moment. Here we go. in bigger. Okay, so in a where clause, what can you do in a where clause? You can compare things using relational operators. And you have for that the ones that probably you are familiar with, which is equal, less than, greater than, less than equal, greater than equal, not equal. So those relational operators all work. You also have the Boolean operators. And they are keywords. They are and, or, and not. Then you have a operator called between. This is generally for dates and integers, so you can say between A and B, and it's inclusive. So if you say, for example, between 10 and 20, you will get tuples that have the values 10 and 20. So this is easier than writing between A and B is just like writing, say, salary greater than equal A and salary less than equal B. So it doesn't add anything to the expressive power of the language, but it's a little easier to read and it's a little more concise. So you can use it for dates. Actually, you can use it for strings as well. You can use it for anything that can be compared using those relational operators. Then we have the keyword in, some set, A, comma, B, comma. So anything, any tuple that matches any of the values in this set will match the query. So this is the same as saying, for example, code equals, say, A, or code equals B, or dot, dot, dot with a lot of ors. So it's a more concise way of having a bunch of ors. Again, it doesn't add anything to the expressive power of the language. It just allows you to specify things in a more concise way. Then we have like, which is used for doing string comparisons, and I will get to that. So I won't say anything now, but this is for strings comparisons. And to check for nulls, there's a way to say is null or is not null. So we'll get to that too. So those are your basic operators or keywords that you're allowed to use in a where predicate. Now, MySQL has regular expressions as well, but we're not going to get into them because we just don't have time in this course. Okay, so what I'm going to do is now just jump into showing you some sample queries and what the results of the queries are. So I'm going to start by showing you the way the database actually gets created. So I will give you the script when eventually, so you can play around with it yourself. So what I'm doing is I'm creating 3 tables. So first of all, I'm dropping the tables if they already exist. Then I create 3 tables, one with the first name, last name, the ID of the student, and their GPA. And we'll get to this, but I think it's pretty, if you read this, it's probably pretty self-explanatory. So if you have a question, please ask it, but otherwise we will get to this when we get to the data definition language in a couple lectures. So I create a table called courses, has a course ID, a course name, and a location. And I create a table called student courses, which shows which students are in which courses. You might think of this as an enrollment. And I could call this instead of calling it student courses, which I will because my queries depend on it, it really could be create table enrollment, because it says what student is enrolled in what course, what grade they got, and what their score was in that course. So then I populate each of the tables with some sample data. So you can see into student, I'm putting Smiley, Vander Zanden, her ID is 1 with a 3.92 GPA. Then I create some courses, course ID CS140, name is Intro to Data Structures, taught in Claxton 103. And finally, in my enrollment, insert into student courses values, and you can see not really easy to tell what the student is because you'd have to look at the student ID. So in fact, student 1 is Smiley. So in fact, we are saying Smiley is enrolled in CS 140. She received an A- and had a score of 89. Okay, so this is a script. Notice that the words create db.sql. So SQL scripts can be executed at the MySQL command line, and we'll get to that on Tuesday. For this particular thing, I simply imported it into my particular workbench. So I have these 3 relations, okay? And what I want to do is do some queries on those relations. So for example, let's say that I want to find all students who have a GPA. So here's hopefully, if you're in the classroom here, see if I can make this bigger somewhat. Okay, so I will select star from, let's see, students, and I want all students that have a GPA greater than 3. Okay, so very simple. The star indicates that I want all columns from the students relation. Okay, and you can see here actually it's students, so I need to make sure that it's right. So I say go, and down here is the result. You can see there are 3 students that have GPAs greater than 3. Now let's say that I wanted that sorted. What I could do is use the order by, and that will sort it. So by default, it will sort in ascending order. Okay, so it's ordered on GPA, it's now in ascending order. But I could instead say order by descending, DESC, and now it would be in descending order. And I'm allowed to have secondary keys if I want it. So if there were ties, which there are no ties here, all the GPAs are distinct, but there could be ties, in which case I'm allowed to have a secondary sort key. So this would say order first on the primary field, which is GPA, but if there's ties, break the ties by sorting secondarily on ID. And you can have as many comma separated ones as you want. Okay. So now let's say that we don't want the ID. All we want is the first name, the last name, and the student's GPA. So we need to look at the structure, first name, last name, and GPA. So now we're specifying a subset, and you can see that we got just the first name, last name, and GPA. And let's say now we want all GPAs between 2.5 and 3.5. We could do it that way. You can see I'm not bothering with upper and lowercase, even though it'd probably make it, it would, to be honest, make it easier to read if I were using uppercase, but for simplicity, I'm not. But you can see again, I got all the ones between 2.5 and 3.5, and it included those that had 2.5 and 3.5. So I think that is probably fairly simple. Now there's a few more complicated things. So okay, so here we have courses. Let's say that I want all courses that start with a CS prefix. Okay, so I don't want EE or accounting or sociology. I just want CS courses. The way to do that is we will select from courses. Nope, select star from courses where the course ID is like. So this is the keyword I showed you before for string comparison, where it's like, and you see CS, and then this is the wildcard character. For those of you familiar with regular expressions, they would use typically a star to indicate 0 or more instances, but in SQL, they chose the % sign to indicate 0 or more instances. So if I do run this query, I get all courses that start with the CS prefix. And I could have, if I want it, you can put that in front. So you can put the % sign in multiple places. So this would say any course that has CS in it. If I wanted all 101 courses, I don't care, all 100 level courses, I could say instead like 1 underscore, no, this looks funny. But what this is saying is I want all courses that have a 1XX. So the underscore matches exactly 1 character. It's like the period in Perl or Python regular expressions. So here, this one was %1, and I had 2 underscores here. So I want all courses that have any leading stuff, then start with a 1, then they have 2 of anything, and then anything else. Now, of course, I suppose I could have really said like that, but specifically, I want to make sure they have at least 2 things after them, because the percent sign would say 0 or more. So the underscore essentially is forcing us to have a character there. Okay, so now this gives me all the courses that start with a 1. Okay, so as I said, this is fairly weak, and there's a more powerful package called the regex package that the book alludes to, and we're not going to talk about. Feel free to look it up, and later on, feel free to use it. But like takes care of, I think, most of your use cases. So questions about like. Okay. So then there is another thing. I actually don't have any examples. So I'm going to have to go back to my PowerPoint slides. So define null. Okay, here we go. So if you want to find every tuple that matches a null, you can't say equals null. So let's say I want to list the details of all viewings. Bigger. So I want to list the details of all viewings on property PG4 where a comment has not been supplied. That would mean that the comment field is null. The way that you test for null is you actually say comment is null. You don't say comment equal null. That doesn't work. Okay, so you have to use is null in order to retrieve tuples whose column has a null value. And if instead I wanted the viewings for this property where the comments were not null, then I would say is not null. So it's a gotcha. You may well make that mistake. It happens. But that is the way you test for nulls. Is null or is not null. Okay. So any questions about basically what we've just talked about are queries on single relations. Okay. So it's select some columns from a relation where some predicate. Now, I guess just a couple other quick things. First of all, let's see, get out of here. When you do things from your columns, you're actually allowed to rename columns. So for example, I could have said select course ID as course name from courses where course ID like that. And you'd see in the result, it says course name rather than course ID. So you're allowed to use the as to give another name to a column. Generally, you don't do it for natural column names, but you'll see sometimes you are allowed to do things like divide. So I could say select salary divided by 12 as monthly salary. And now that has a bit more meaning than seeing if I just write it like that, SQL will literally put salary divided by 12 as the column heading in the result. So if I want a more mnemonic name, I would say as, and then I would put it there. I'm also allowed to assign so-called aliases to my table name. So I could say from courses C. Now this isn't going to, you'd never do this for a single table query, but for a multi-table query, it turns out that sometimes you have to disambiguate attribute names because two relations could have the same attribute name. So when we get to multi-table queries, we start having to prefix attribute names with the table names, and then it's sometimes easier to just provide a one-letter alias for the table to make it so I can say now where C dot course ID like, rather than having to write courses dot. Now there's no ambiguity in a single relation query, so you'd never do this in a single relation query. Like I say, when we get to multi-table queries, that changes. The other thing you need to be a little careful about is that sometimes queries can return duplicate tuples. So let's just see here for a moment. So for example, let's say that we look for all courses with Smiley. So with just a second. Okay, so let's say we do all student courses with student ID equals 1. Okay, and if I do go, you'll notice there's duplicates here. So you oftentimes, first of all, this is actually an invalid relation. Remember that in the relational model, you cannot have duplicate tuples. Here we have 3 duplicate tuples, but SQL is forgiving of that. But oftentimes you don't want duplicate tuples in your output. So you can get rid of duplicate tuples by saying select distinct. If you say select distinct, then it will remove duplicate tuples. And that is sometimes a helpful thing to do. So that's a couple other bells and whistles with your select statement. Okay, so those are fairly simple. So let's move on now to what are called aggregate queries. So let's take a look at student courses. So let's say that we want to know, see, we have a lot of enrollment here in CS140. Let's say, and sociology and the like. Let's say we want to know the enrollments in each course. Okay. To do that, what we'd like to be able to do is count all the students in CS140. Here's 1, here's 1, there's 2, 3, 4 students in CS140, but we'd like to count the number of students in each course. This is what is called aggregation, where what we want to do is essentially separate or group, actually better word is group. We want to group related sets of tuples together. In this case, we want to group all tuples with the same course ID together, and then we want to count them. Okay, so there is a group by that will do that, and then there's some aggregation operators. So what I'm going to do is say select course ID count star. So count is a aggregation operation. It counts the number of instances of a tuple from student courses. Now I'm going to say group by course ID, because I want to group all tuples with the same course ID together. And then what it's going to do is, once it's grouped them by course ID, it's going to count the number of instances. So when I say go, it has counted. See here, CS140 has 4. A counting 140 also has 4, a counting 102 has 5. Notice how this irritating count star showed up. This is why we like to be able to use aliases. So here we would actually probably say as enrollment. And now it would look a bit better, course ID and enrollment. Okay, and I could now, it makes it easier to also order that way. So now I'd like to actually order by enrollment. So also by naming it, it makes it easier to specify it in other clauses. Okay, now let's say I want all courses with an enrollment less than, say, 3. So now I could say having enrollment less than 3. Actually, less than equal 3. So this having clause allows me to select only those groups whose enrollment is less than or equal to 3. It looks like I have an error here. See if I really do. Yep. Unrecognized statement type. Ah, that's because I have a semicolon. Okay, so now it gave me all, it eliminated those groups whose enrollment was greater than 3. So this gives you the essential elements of grouping. You group on one or more attributes, and then all tuples or rows having the same value will be grouped together. And then you can apply an aggregation operator to them. And there's 5. There's count, there's min, which gives you the minimum. There's max, which gives you the maximum. There is sum, which will sum up all the elements in that group. And there's average, which will take the average of all elements in that group. Okay, so the aggregate operator is applied to all the elements in each group. Then you're allowed to use this having to filter out groups that you don't want based on the aggregation. Okay. So let's just look at that on the slides. Okay, so your aggregate operations, again, they're applied to each of your groups. If you don't specify a group by, and that's okay, you can specify these aggregate functions on an entire relation, then it will be applied to an entire relation. If you say group by, then it will be applied individually to each group of related tuples. Okay, so one important thing is what happens when you have nulls in the field. So all the numeric functions eliminate. So min, max, average, and sum eliminate the nulls because there's no sense operating on nulls. Only count counts nulls. So count will take into account null values. Sometimes you only want distinct. So you could say count distinct here. Instead of star, you could say count distinct, and then it would remove duplicates. Okay, when you use distinct, it has no effect, obviously, with min and max, but it could have some effect on sum and average. Okay. Because if you have, for example, if you had the tuples 3, 3, 3, and 5, and you do an average on these, you will get 14 divided by 4, which is 3.5. But if you say distinct, you'll end up with 3 and 5, and your average is going to be 8 divided by 2, or 4. So distinct could influence your average and sum. But obviously, min and max are not affected because eliminating any number of 3s is still going to leave a 3 in there for the comparison. Okay, so you can apply, a sec. Now, coming back here. So count, min, and max can be applied to both numeric and non-numeric fields. Sum and average can only be used on numeric fields. Okay, so let me.
Dr. Van den Zanden?
Yes.
Max and min on non-numeric, does it compare all characters? Does it go through the entire string?
Yes. So the question is min and max on non-numeric data. How does it do it? It depends on the data type. So if it's a string, it will do lexicographic comparison using all the characters in the string. If it's a date, it will compare it using our intuitive notion of a date. So June 1st, 1990 would be less than June 1st, 2000. Okay, so there are other non-numeric data types than just strings. Dates are an example of a non-numeric data type as well.
Capital A is greater than little a?
Oh, I always forget my ASCII stuff. I think actually capital A is less than little a. I think the capital letters come earlier in the ASCII codes than the small characters.
Okay, it's based on ASCII though?
Yeah, it's based on ASCII.
Okay.
Actually, more recently is probably based on Unicode. But Unicode preserves ASCII orderings.
Okay. Good to know. Thank you.
You're welcome. Other questions? Okay, so someone just said that I was right, that uppercase actually does come before lowercase. Also, when you're comparing stuff, it does funny things with numbers. So for example, you just got to be careful in your comparisons because numbers, if I have a string 110 and I have a string 1, that's trying to think of what the comparison is that gives you something you don't expect. What is it? Oh, I think is that it? No, I can't. Sorry, there's sometimes when comparisons of, if numbers are strings, you're going to get results that are unanticipated. But I'm struggling off the top of my head to come up with an instance of that. But I just remember that when you're comparing numbers as strings, sometimes you'll have something where naturally 20 is less than 200, but for some reason, when you compare them as strings, you would get 200 being less than 20, but I forget exactly the situation and what that and when that happens. So I will try to figure that out for you. Just know that you have to be real careful when you're comparing numbers that are strings because they don't always come up with the right ordering that you would expect. Okay. So what I want to get to is, okay, couple things. Let me keep going. So first of all, don't use, sometimes people try to sort using group. Don't do that. Group by and order by are two different things. And sometimes on the homework assignment, when I ask you to do sorting, people notice that group by seems to sort things by that particular attribute, but it's not reliable. It's not in the standard as far as I know. So if you want things sorted, you actually have to say order by. Okay. So there's a distinction between having and where. Where filters individual tuples. Having filters groups. So having is used with a group by operator, and generally having has an aggregation operator in the comparison because it is filtering groups. So that's an important distinction. Group by and having go together, select and where go together. You might have where and having in the same thing. So for example, I might say, let's see, go back to my select course ID as enrollment from student courses, group by course ID, having enrollment, order by, but I might say where course ID like, say AC, Okay, and now what I'm going to get, I should get all the accounting ones, except that obviously I didn't. It's AC, no, it is AC. What did I do wrong? Where course ID like, oh, there's none that have an enrollment less than, so, there we go. Okay, so coming back here. So here I selected course ID from student courses. The where gets applied first. So it eliminates all tuples that don't start with the AC prefix. After the where is applied, then the group by is applied. So the where has priority. First, the where filters out any tuples we don't want. Then the group by is applied to the remaining tuples. And like I said, in a having statement, one of the fields should be a aggregate column. So here it's really saying having count star less than equals 4 because I renamed count star as enrollment. Okay, so the having is generally comparing an aggregated result. So you're restricted in what columns you can select when you're grouping. When you are grouping, the only columns you're allowed to select are the ones that you group by. Okay, and that is because you are generally aggregating some information for that attribute. Okay, so if we look at student courses, trying to leave that. Let's say, remember we said we wanted to count the number of students. So let's say that we tried to say select course ID grade. So let's say we go back to here and we also say select grade. Well, what grade are we talking about? The problem is there are, in the accounting class, there's 5 students. Which of the 5 students' grade should show up in this result? It's ambiguous. So you're not allowed to use fields that you're not grouping by. You can only select fields that you're grouping by, and then your aggregation fields. Okay, now that creates some issues. Let's say that I want to find, let's go to student courses. And what we're going to do is find the minimum and maximum score in each of the courses. So let's do select min score, max score from student courses. Group by course ID. So for each course, we want the minimum score and the maximum score. Okay, that's nice. It gives us minimum and maximum. We'd probably like to know for what the course ID is. That's nice, but what might we also want to know along with the minimum and maximum score? Which student it was. Okay, and there's not an easy way to get at it. Okay, so we will talk about that. One thing you're allowed to do is it works for non-grouping operators. So for example, I could say select min student ID from students. It doesn't like that because student is not its student. Still doesn't like it. Select min. Look at student. It's named ID, not. Okay, so that's nice, but it doesn't give me which student is associated with that ID. So what I can do in that situation, let's go to my notes so that I get it right. I think I actually have it here, sorry. Okay, here we go. So what I'm going to do is a slightly more natural one. We're going to select, instead of student ID, we're going to select the minimum GPA. So we'll go to SQL and we'll select the minimum GPA. Okay, which is nice, except that that gives us that, but it doesn't give us who that GPA is. So now we might try this little stunt. Select star from student where min GPA equals, except it's no good because we don't know what the minimum GPA is. Or we'd like to be able to say this, where GPA equals min GPA. Okay, let's give that a try, and it's not going to work. Error and invalid use of the group function. Basically, you can't use aggregation operators in your where statements. They're only valid in having statements. So this is a pain in the neck because we'd really like to know which student had that minimum GPA. So SQL has variables. So what I can say is select at GPA equals min, colon equals min GPA from student. So at GPA is an SQL variable. And this is an assignment statement saying it's equal to min GPA. Okay, so I can run it, and now I have at GPA as a temporary variable. Now I can say select star from student where GPA equals at GPA. Just a second. Should have worked. Maybe GPA equals from student. They have to be in the same. There. What? Okay, there we go. So it may have been that I didn't have it may have gone out of scope on me, but this one executed 2 queries. The first one set at GPA to the minimum GPA, and then the second one found that Bugs Bunny had that GPA. So you can use temporary variables like that, and it works out pretty well. We will show you some other ways to get this using subqueries, but that's for another day. So any questions about the grouping operators? Okay. In that case, we will move. Yes? Go ahead.
Simple question, I think. Is there any way to stop a select statement once you put, I guess, just any statement with a semicolon? Is there any way to stop it from presenting its results? Like for your first select at GPA, could you not have it print the results and just have it print the results of the second select?
I think so, but I forget how to do it.
Okay, never
Pretty
mind.
sure that there is some kind of suppress statement, but I don't know that for a fact. So good question. The question was, can I suppress the printing of, all I cared about was Bugs Bunny. I didn't care about this right here. So the question was, can I stop SQL from printing this table? And I think the answer is yes, but I can't remember what the command is to suppress it.
No problem. That was a bit out of left field.
That's okay. It's interesting because you just don't think about it, and then question comes up, and it's like, yeah, I think I saw that somewhere once 10 years ago, but I can't pull it out of memory.
No problem. Just
Gotcha. Okay, so let's head then to the insert delete.
I wanted to point out that I just got an email that the database for this class has been created.
All right. Actually, that's important enough. Did others of you get that message too?
Yes.
Yeah, I got it.
Okay, that's actually important enough that, great. Let's just take a look at that. In fact, I think I'm going to quickly instead have you all do that rather than, okay. So names of the databases. So first of all, just quickly, I have a website. On my website, I have some notes about getting started with your SQL database, getting started with your MySQL database. Okay, so at the command line, what you can do is you'll have to log into a departmental computer. Okay, and then you can type MySQL, and then this thing tells you the database server. The -H is the database server, which is DBS2. Then P says to prompt for a password, and saying my one is cs465 underscore B Vander Z. Then you say -U for your username, and then it will prompt for a password, and you're in. And the very first thing you should do, and I'm going to not worry about that just now, but the very first thing you should do is change the password. So set password. So you can say set password. I'm not going to show it everyone, but you would say some password at the command line. And then the important thing is creating your own executing scripts. So I created that set of relations using this script, which you can get to. by following exactly this directory. So if I source it, copy and source this, you can see that it mostly worked. There were some unknown tables, but otherwise, when I'm done, I can say select star from student. There it is. Select star from courses. There they are. Okay, so you can, doing this, you can now basically get started with your homework. So log into UTK, follow my simple set of instructions and what you were given with the email you received, and you should be able to get access to your databases. And like I said, I give you scripts to create databases for homework 1. These supplementary files include exactly that. I know it's somewhat small, but it gives you some sample data. You run the script and it will populate your database with the sample data. Now I will tell you, it's from 2020, so you need to, I need to update it. I just realized I need to update all these dates to 2021, otherwise none of your queries will work. But at any rate, you can run these, you can run scripts using the source command. Okay, so any questions about that? Okay. That was huge. That is great. Okay, so just quickly, insert, delete, and update. The only one you're going to have to worry about right now for your homework, so I'm going to go over, is the insert command. You may want to insert some of your own data. Don't worry about delete or update. I'll talk about those on Tuesday. But insert, if you want to insert a tuple, the syntax is insert into table name. This is an optional column list. So you only provide the column list if you want to specify the set of columns that you're assigning data to. For example, if columns can have null in them, you can omit them from the values list. But if you're going to provide, and the other thing is, if you say insert into table name values, then, and you ignore the column list, you don't provide one, you have to provide the values in the exact order that you declared the attributes in your create table statement. So when I created the student table, the order of the attributes was first name, last name, ID, GPA. So down here, where I said insert into student, you'll notice I didn't provide a column list. So when I gave it the values, it had to be exactly in the order that the attributes were specified in the create table statement. But if I provided a set of columns, I could have changed it. I could say insert into student, GPA, ID, last name, and then values. And now it would be assigned based on 3.92 would be assigned to GPA, 1 would be assigned to ID, and van der Zanden would be assigned to last name. And null would be assigned to first name because there is, in this list, I didn't provide first name. So the reason for providing a column list is either you don't want to provide values for all of the fields, in which case they will be assigned null, or you want to change the order, which I have no idea why you would do that. Okay. If null is not a valid value, for example, for a primary key, the insert statement will fail. So it's, you could get a failure if it violates a referential integrity constraint or an entity integrity constraint. Okay, so with that, you should be able to insert your own values into the database. Okay, and yep, don't worry about update or delete. We'll cover those on Thursday. So any questions about insert? I think it's pretty simple. Okay. Actually, let me just quickly, you may decide after you've, let me just say delete, because let's say you do an insert and you don't like it. It's very simple to delete a tuple from a table. It's delete from table name where search conditions. So if you do an insert and it's a bug, you say, whoops, I didn't mean to do that. Like I entered 2020 dates rather than 2021 dates. This is how you can fix your problem. Delete from table name where search condition. And it will delete all tuples that meet the search condition. So again, pretty simple. Okay, so with that, I will let you all go. You should be able to get started on the homework assignment, and I will see you on Tuesday. So anyone who has questions, feel free.